Hello, good afternoon. All B.Sc first semester chemistry students of Pipin Chikkati Degree College. Today, let us have some general information about the mode of conduct of examinations, theory as well as practicals. And this year, Karnataka University is introduced CBCS system for degree classes. Okay, friends, this year you have 100 marks for theory and 50 marks for practicals. And total 100 marks theory, you have 4 credits, and for practicals 2 credits. In total, there are 6 credits. You can see here, CBCS means choice based credit system. That means it is the choice of a student can choose the course or the subjects. It is known as a D.Sc, discipline specific course. Say for example, some of you have opted PCM combination and CBZ combinations. This PCM is a discipline specific course, contains physics, chemistry and mathematics. Like that, CBZ, that is also a D.Sc, discipline specific course of chemistry, botany and zoology, along with the languages, and also one compulsory subject for every semester, that is what is known as Ability Enhancement Compulsory Course, AECC, that is Ability Enhancement Compulsory Course. This is also known as compulsory subject for a particular semester. For this semester, you have this Ability Enhancement Compulsory Course, that is environmental science. Whether the PCM or CBZ students, all of you should study this AECC, Ability Enhancement Compulsory Course, that is environmental science, for 50 marks, and for 100 marks English and another subject language, that is Kannada. But as far as the core subject, that is chemistry, is concerned, you have 100 marks theory and 50 marks practicals. And further it is classified or divided like this. You will write examination for 80 marks, and that examination will be of 3 hours duration, and another 20 marks you will have internal assessment. Internal assessment means we normally conduct 2 tests, and the average of the 2 tests for 20 marks, we convert that 20 marks into 10 marks scored for test, and another 10 marks we give it for assignments. We give some questions for your home assignments, then you will write the answers for the given questions in the home, that is known as home assignment, or simply it is called assignment, for 10 marks. 10 marks the test, internal test, for which we conduct in the college. Then for another 10 marks we give some assignments, and you will answer the questions in the home or in a separate answer book, that is assignment book. That is 10 plus 10, 20, plus 80 marks theory, so total 100 marks. You take for example this practicals. At the semester end examination, you will appear for the practical examinations, that will be there for 40 marks. So you will be given one experiment. For that you have to carry out the experiment, and you should finish it in 3 hours during the examination. That contains 40 marks. Assessment will be made for 40 marks. Then what about for another 10 marks? Again here also we conduct one practical test. Then it is reduced to 10 marks. Out of 10, some of the students may score 10 out of 10 or 9 out of 10, like that. Though that marks will also be added. Totally there will be 50 marks practical, 100 marks theory and 50 marks practicals. Totally you will study this chemistry for 150 marks in the first semester. The same procedure will be repeated for second semester. Only thing, the topics which will be covered in first semester and second semester are totally different. This is all about some information regarding the conduct of classes, practicals through this CBCS system, choice based credit system. For first semester you will have 6 credits, and for second semester again 6 credits. For the B.Sc first year, so to complete B.Sc first year you have to come across 2 semesters, 6 plus 6, total 12 credits you have to face, or 12 credits you have to complete, then only you can complete B.Sc first year. This is the general instructions for our students, and it is instructed by the Karnataka University, Dharwad. Okay, as far as the very first topic of your B.Sc course, that is chemistry, is the structure of the atom. It is said in the syllabus, it is the review of structure of an atom. Friends, you all know that all elements, whatever the number of elements known so far or discovered so far, are made up of their own atoms. All the atoms are identical, and atom is a tiniest particle of an element. The atom which possesses certain amount of mass, that mass is due to the presence of nucleus at the center. Nucleus further contains the particles like protons and neutrons. Proton possesses 1 unit positive charge with a unit mass, whereas neutron has only 1 unit mass and has no charge. This electron has got the mass. Mass of an electron is very negligible. It is known as rest mass, and it carries 1 unit negative charge. An electron is always being charged. It is revolving around the nucleus in its path. The path of the electron which revolves around the nucleus is known as the orbit. The path assigned to an electron to revolve around the nucleus is known as the orbit. It is an orbit. It is a path. So this is the basic information given by this Rutherford. Earlier to Niels Bohr, model of an atom. Niels Bohr in the year 1931 proposed the structure of an atom. Before that, this Rutherford assumed like this. Of course, all the atoms of the elements are identical, no doubt. The mass of an atom is concentrated at the center. It is known as nucleus. Further, nucleus contains nucleons, namely protons and neutrons. That is also correct. And the smallest particle with rest mass and a unit negative charge, known as electron, is revolving around the nucleus. It is also correct. This is the assumption made by the first and foremost scientist Rutherford with respect to the model or the structure of an atom. It says, and he predicts like this: when the electron with 1 unit negative charge with rest mass, when it revolves around the nucleus continuously, then it loses its energy, and ultimately when it goes on losing the energy and ultimately it falls into the nucleus of a particular atom, then the structure of the atom collapses. This is the assumption made by Rutherford earlier to Niels Bohr. Then by considering this idea, Niels Bohr proposed his own theory of structure of an atom in the year 1931, and he proposed the model of an atom with the following postulates. He also assumed, and whatever the assumptions made in the Bohr's theory of an atomic structure is accepted by the classical theory as well as Planck's quantum theory, and the following postulates are made by this Niels Bohr. According to Bohr's theory, the very first postulate is like this: atom is the smallest and tiny particle, contains the nucleus as it was assumed by this Rutherford. This is correct. All atom elements consist of their atoms. Atom consists of the tiny particle or the smallest particle, that is what is known as nucleus, and entire mass of an atom is concentrated in the nucleus. This is the very first postulate given by Niels Bohr. Next one, the electrons revolve around the nucleus, and the path of the electron which revolves around the nucleus is in the circular shape. This is the assumption or the postulate given by the Bohr. At the earlier days, the postulate was accepted by the other scientists, and later the electron is revolving in the circular path as well as in the elliptical path is suggested by another scientist, that is Sommerfeld. It is the next part of the discussion. The second postulate of Bohr's theory is electrons revolve around the nucleus in a circular path, and third postulate is every orbitals, that is the path of the electron is known as orbit. Orbital is one in which the probability of finding an electron is more. Suppose simply if you write a circular shape, then that is path of the electron in which it can revolve. Suppose an electron is there, you take a very first element, that is hydrogen, its atomic number is 1, only one nucleus that contains a proton, no neutron is present in the nucleus of hydrogen atom. Only one electron can revolve around the nucleus of the hydrogen atom. So definitely the path of the electron or the shape of the orbital is circular in case of hydrogen, and the electron which revolves around the nucleus has got certain amount of energy. It has the fixed amount of energy. That energy is denoted by 1, 2, 3, 4 like that. 1 refers to the first energy, 2 second energy, 3 third energy, 4 fourth energy, and all these first, second, third and fourth are further denoted by the letters, that is K, L, M, N. 1 refers to K, 2 refers to L, M, N, like that. K, L, M, N are also known as energy shells or shells. Energy shells means energy of the electron is fixed. Suppose the first energy, K shell, contains minimum amount of energy. L shell contains higher amount of energy than the K shell. That depends the number of suborbitals present in it. For example, you take a K shell. K shell contains only s orbital, which is very near to the nucleus and has minimum amount of energy. Come to N shell, L shell. L shell contains two suborbitals, namely s and p orbitals. Here s orbital again contains minimum amount of energy, and p orbital contains little higher amount of energy than the s orbital. It is the algebraic sum of the total energies possessed by this s orbital and p orbital in the second shell or the K shell. Like this, as you go away from the nucleus, that is K to L, L to M, M to N, or 1 to 2, 2 to 3, 3 to 4, like that, the energy associated with a particular shell or with a particular main energy that increases, because the main energy, which contains more and more number of suborbitals, the total energy definitely increases, or it differs from shell to shell. And those shells are also called stationary cells. For example, K shell has got fixed amount of energy. It never changes anytime as long as the electron is in the K shell. If the electron goes to L shell, then energy of that electron is definitely higher than the energy of the electron which is present in the K shell. Like that, K to L, L to M, M to N, like that. That depends on the number of suborbitals. Say for example, we all know that by this time we have studied the structure of an atom, the shape of the atomic orbitals, main energies, sub-energies, like that. The main energy, that is a K shell, contains only one orbital, that is s orbital. It has no p orbital. S orbital can take only 2 electrons, minimum of 1, maximum of 2 electrons. Then you come to L shell. That L shell contains 2 sub-shells, namely then S as well as P. For S, 2 electrons, for P from 1 to 6. If the p orbital is completely filled by its quota, total number of electrons present in the L shell are 8. So it is the algebraic sum of the energies possessed by the electrons present in the S subshell as well as p subshell in the L stationary shell of an atom. Like this, why the energy increases as the electron goes away from the nucleus, or as it goes away from one main energy to another main energy, or from one stationary level to another stationary level. But the electron is not stationary. The energy shell is stationary because it has got fixed amount of energy. If you assign an electron in the K shell has got fixed amount of energy. Therefore, it is called stationary energy level. And moreover, according to the quantum mechanics or Planck's quantum theory, the angular momentum of an electron is quantized. It has assigned certain amount of energy. Therefore, it is there in the next postulate. That is, in the fourth postulate, electron neither loses nor gains the energy as long as it is there in the fixed subshell or in the shell. Say for example, you take the electron is present in a K shell, that is the first and foremost shell, or it is very near to the nucleus and has got minimum amount of energy. That electron will simply revolve around the nucleus in the given orbit, that is s orbit only, that is in the circular shape. So it revolves around the nucleus. While revolving, it never loses the energy because it is quantized. The electron moves around the nucleus. It has got the centrifugal force. Of course, I will come to the next postulate, that is in the fifth postulate. The electron, while revolving around the nucleus in its given path, never loses or gains the energy. It simply revolves around the nucleus in the given path. This is this postulate is actually disproved, one of the postulates given by Rutherford. What Rutherford said in his theory, electron continuously loses the energy as long as it revolves around the nucleus and ultimately it falls onto the nucleus. It is disproved by this Bohr's theory. That is the postulate number 4 of Bohr's theory of hydrogen atom, or simply atom, says that electron, the duty of the electron is to revolve around the nucleus because it has rest mass and contains 1 unit negative mass. The nucleus has got 1 unit mass as well as 1 unit positive charge with regard to hydrogen atom. Therefore, electron you cannot assign. Electron will not stand still. It will not a stationary particle. It is always a moving particle. So that while moving in the given orbit, it has got its angular momentum. The angular momentum of a particle is given by an equation, that is mvr, where m is mass of the particle, say electron, v is its velocity, and r is the radius of the circular path of the electron in which it is revolving. So that the while moving the electron while moving in its stationary path, the angular momentum is arised. That angular momentum is due to the centrifugal force or electrostatic force of attraction between the nucleus and the electron, because nucleus and electrons are oppositely charged. Nucleus is positively charged whereas electron is negatively charged. Let us come to the fifth assumption or the postulate of Bohr's theory of hydrogen atom. This electron has the angular momentum. Just now I told, the angular momentum of any moving particle is calculated or given by the equation mvr. M is mass of that particle, v is the velocity, and r is the radius of the circular path or the path of that electron. Mass is its m is its mass because it has rest mass. No particle is going to exist without any mass in the universe. And this v, velocity of light is equal to velocity of light, and r is the radius. Next postulate is very important postulate to disprove the whole theory. It was given by this scientist Rutherford. Electron, when they are moving or the electron is present in its stationary shell or a stationary orbit, it can absorb the energy while going from ground state to the elevated state. That is, when an electron absorbs certain amount of energy, it gets excited so that it is ready to leave its original state or ground state. Okay. When it absorbs energy, it jumps from K shell to L shell. How long it absorbs the energy? The electron, when it is in the K shell, it is going to absorb the energy which is almost equal to the energy of the L shell. Then only it gets excited and leaves its ground state and goes to the first excited state, or it goes to L shell. If you go on supplying energy or the electron go on absorbing the energy, it can leave that L shell also. If the absorption of energy is almost equivalent to M shell, then it goes to second excited state. And any excited electron never tries to reside in that excited state. It is the basic property of an electron, excited electron. When it absorbs the energy, it leaves the ground state and goes to the excited state. And the supply of energy or the absorption of energy process is in progress, then that excited electron further goes to the further excited level. It goes to first excited, second excited, third excited, fourth excited, like that. And it never remains there only in the excited state. It tries to come down to its ground state or original state as early as possible. That means the energy is emitted by an electron when it is in the excited state. Say for example, the difference in the energy, that is E2 is the energy of an electron in the first excited state. E1 is the energy of the electron when it is in the ground state. The difference is delta E. That delta E is E2 minus of E1. That E2 minus of E1, that means the energy emitted by an electron, excited electron, while coming down to the ground state is in the form of radiation. That radiation is nothing but a photon. That delta E is equals to h nu, where h is Planck's constant. It is experimentally determined constant. It has got the value, and nu is the frequency of the radiation emitted by the electron. There are two possibilities. Whenever the electron absorbs energy, it goes to the excited state, no doubt, and you can find the spectrum for this. This is what is known as absorption spectrum. When the energy, electron absorbs certain amount of energy which is equal to the frequency of a certain colored light in the visible region, so that you can what is known you can call it as the absorption spectrum. When the electron emits the energy coming down from the excited state to the ground state, it never comes all of a sudden from fifth energy state to first energy state. It comes to fourth, fourth to third, third to second, second to ultimately first energy or to the ground state, so that the frequency of energy emitted by the excited electron is equal to the wavelength of any colored light which can be seen in the visible region. Therefore, this hydrogen gives the spectrum, what is known as hydrogen spectrum. Spectral lines we can obtain. That spectral lines are due to the difference in the wavelength, different wavelength or the energy emitted by the excited electron with different wavelengths corresponding to a different color in the visible region. This is how this postulate number 6 helps us to explain the line spectrum, or what we call it as fine spectrum, obtained by this hydrogen atom or the excited electron in the hydrogen atom. And why we have considered only this hydrogen atom, why not the other atoms such as helium, lithium, boron, so on and so forth. Hydrogen is the very first element present in the periodic table with atomic number 1. The charge of the nucleus is Z equal to 1, and it contains only one electron. If we are able to understand the structure, the behaviors of the electron in the hydrogen atom, then we can explain the structure of the atoms with higher atomic numbers, namely helium, lithium, then boron, like that. On the basis of postulates of Bohr's theory of hydrogen atom, we can derive the radius of the Bohr's orbit for the given electron. So this is what is known as the derivation of the expression for radius of hydrogen atom. Bohr's theory mainly explained about the structure of the hydrogen atom, and hence we can derive an expression for a radius of the electron of hydrogen atom. Dear students, we all know that there is the electrostatic force of attraction between the nucleus and the revolving electron. Okay, let us assume like this. This is the hydrogen atom. At the center there is a nucleus which is positively charged. and around the nucleus in a circular path the electron is revolving with the charge E minus with a velocity of v, and the radius of this circular path will be r. Because of the electrostatic force of attraction between the electron and the nucleus, so it has two forces. One is the centrifugal force, the other one is the centripetal force. Centrifugal force is nothing but the electron is always wants to be away from the nucleus. Though it is revolving in its circular path, because of the centrifugal force, it always tries to be away from the nucleus, and the electron, this is what is known as outward pull of the electron. And the centripetal force, the nucleus always tries to hold the electron towards it because of the nuclear force of attraction, and this is what is known as centripetal force. Centrifugal force is exactly equal to the centripetal force, and hence nucleus is always at its center and the electron is always revolving in the given path or in its path only. So that leads to the existence of the hydrogen atom. Due to electrostatic force of attraction between the nucleus and the electron, we can write Z E square upon 4 pi and epsilon 0 r square. This is the one basic equation with the certain constants, where Z is the atomic number or the nuclear charge, and E is its charge. Then 4 pi is again a constant, epsilon 0 is a constant, where r square is the radius. This is the first equation, and epsilon 0 is what is known as permittivity constant. This permittivity is nothing but the medium. That medium is vacuum in this hydrogen atom, or in this case. So that epsilon 0 has a constant value, therefore it is 8.854 into 10 raised to minus 12 coulomb square per joule. This is an experimentally determined quantity. We can use this as a constant. And one more equation. We know that this centrifugal force is given by this equation mv square upon r. This is equation number 2. So with these two we can write Z E square upon 4 pi epsilon 0 r square is this is, if it is centripetal force, and this is centrifugal force, mv square upon r, or you can write v square is equals to Z square upon 4 pi epsilon 0 mr. This is equation number 3. Because of the cross multiplication, it is a simple mathematics. And mvr, that is the angular momentum. Due to that angular momentum, the momentum of the electron, the energy of the electron is quantized. mvr is equal to nh upon 2 pi. This is equation number 4. Again n is the number of the orbit in which the electron is present, where h is Planck's constant, or v equals to nh upon 2 pi mr. On squaring the equation, we get v square equals to n square h square upon 4 pi square m square r square. This is equation number 5. Comparing the equation number 3 as well as equation number 5, we get again Z square upon 4 pi epsilon 0 mr is equals to n square h square upon 4 pi square m square r square. This is equation number 6. And you can write this r is Rn, then it is epsilon 0 n square h square upon pi me square z. Z is again the charge of the nucleus, that is what is known as atomic number. Atomic number here in this equation for hydrogen is 1. Therefore, Z equal to 1 means Rn is equals to epsilon 0 n square h square upon 4 pi me square. This is equation number 8. This equation number 8 refers to the expression, or you can calculate the orbit of the electron in the hydrogenic ions, means hydrogen like atoms such as hydrogen, then this helium cation, lithium divalent cation, boron trivalent cation. So that the electron is always in the species present in the first orbit, and this is one of the important equation. We can use it for the calculation of the radius of the Bohr's, it is what is known as Bohr's radius of the Bohr's orbit. Whatever may be the species, it may be hydrogen, it is basic one, and next helium cation, where helium is the atom contains 2 electrons. If you remove one electron from it, only one electron remains in the 1s orbital of helium plus, He plus. It look like the hydrogen atom only, though it is charged, but number of electrons and the radius will be same, so that only one electron will be there. Whatever may be the species, if there is only one electron in the orbital, that you can calculate the radius of that orbital. With this, where Rn is general for first Bohr orbit, if you substitute the values, you can get one radius, that is the radius. Then for second orbit, third orbit, up to nth orbit you can calculate using this equation. For example, let us take one example for calculation of radius of the first Bohr orbit. With this energy expression, to verify this, this is the equation for nth orbit, calculation of radius of nth orbit. Even we can go for the calculation of radius of first orbit, second orbit, third orbit, like that. Let us consider one example, that is the calculation of radius of first orbit. Calculation of radius of first orbit. For example, for hydrogen atom, nuclear charge, that is Z, or you can say atomic number, is 1, and for the first permissible orbit, nearest to the nucleus, As I said during the course of the derivation, if the electron is very near to the nucleus or in the first orbit, its energy is very minimum, then n equal to 1, nearest to the nucleus, here n equal to 1. That is, for R1, epsilon 0, n square means 1 square, that is 1 only, and h square upon pi m e square. This is the equation. Rn is equals to epsilon 0 n square h square upon pi m e square. It was the expression. Substitute the values of epsilon 0, h, pi, m and e in the equation, and these are the constants. Epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per joule per meter, it is its unit, and m is mass of the electron. It is 9.108 into 10 raised to minus 31 kilogram kg. Then h is Planck's constant. It is 6.624 into 10 raised to minus 34 joules, and pi, again it is also a constant, 3.14. When you substitute all these constants in this equation, you get 8.85 into 10 raised to minus 12 into 6.624 h square into 10 raised to minus 34 square upon 3.14 into 9.108 into 10 raised to minus 31 into e square, 1.602 into 10 raised to minus 19 square it is. After simplification, you will have 0.5292 into 10 raised to minus 10 meters. This is the radius of the first orbit, and you can convert this into angstrom units, that is 0.5292 angstrom. As we all know that 10 raised to minus 1.0 into 10 raised to minus 10 meter is always equal to 1 angstrom unit. This is how the first Bohr orbit radius can be obtained from this equation. Let us go for another example, that is for the second or even the fourth orbit, radius of the fourth orbit of the hydrogen atom. That is problem like this: calculate the radius of fourth orbit of hydrogen atom using the radius equation. The answer or the solution will be Rn equal to n square R1, where R1 is radius of the first orbit, radius of the first orbit. It is just now calculated as 0.5292 into 10 raised to 10 meters, Now, therefore, for R4 is n square. N is equal to 4 now. N square means it is 4 square into 0.5292 into 10 raised to minus 10. That is, you get 16. 4 square means 16 into 0.5292 92 into 10 raised to minus 10. That is further equal to, finally you will get 8.4672 into 10 raised to minus 10 meters, or you can write 8.4672 angstrom units. This is the radius of the fourth orbit. With this help, you can also calculate the radius of the third orbit. Radius of the third orbit, where n equal to 3. That is for helium cation. It is nothing but the hydrogen atom only, because in helium, after the removal of one electron, still it contains only one electron like hydrogen atom. So that Rn equals to n square into R upon Z, that is the nuclear charge here for helium cation. Z is equals to 2, that is its atomic number. For third orbit, you will have R3 equals to 3 square into 0.5259 into 10 raised to minus 10 upon 2. 2 is the atomic number or nuclear charge of helium cation, that is 3 square is 9 into 0.5259 to 10 raised to minus 10 upon 2. So you get 9 into 0.5259 into 10 raised to minus 10 upon 2 is equals to 2.3184 into 10 raised to minus 10 meter, or 2.3184 angstrom unit. This is what is known as the radius of the third orbit of helium cation. This is the radius of the fourth orbit of any atom, say hydrogen atom, like that. With this radius expression, we can calculate the radius of any orbit of a given atom. This is all about the expression, derivation of the expression for a radius of Bohr's radius of the hydrogen atom, and also the calculation of a radius, value of radius of first, then third, fourth, even sixth or eighth, or up to nth orbit of any given atom of a particular element. Thank you. Let us see in the next period for the further topic. Thank you.